Hello everyone. In this problem, there is a synthesis reaction. So molecule A and B react to form molecule C. And in the chemical formula, we don't know the coefficient of A. And two experiments were performed. And in the second reaction, A molecules are all consumed. So if we compare the first and second reaction, in the first experiment, less A and B were used, and then in the second experiment, and the decrease in A is greater than decrease in B. In A, there is a 50% decrease, but in B, there is only 25% decrease. So if A is the limiting reagent in the second experiment, A will be also limiting in the first experiment because less A was used than B. So in both experiments, A molecules are all used up, and there will be some leftover in B. And I'm going to assume that both the A and B are diatomic molecules, so that I don't have to split the atom to make new molecule C. So let's say A is made of 2 p atoms and B is made of 2 q atoms. In such case, C will be made of A number of p atoms and 1 q atom for the balanced reaction. And we compare the density of the gases before and after the reaction. And in both the experiments, the density after the reaction increase. That means the volume of the gas will decrease after the reaction because density is mass divided by volume, and because mass is conserved, increase in density means decrease in the volume. So let's make a table for the amount of each reagent before and after the experiment. So the amount of A before the reaction in the first experiment in terms of mole is 15 times W, that's mass, divided by 2 times atomic weight of P, that's the molecular weight of A. And before the reaction in the first experiment, the amount of B in terms of mole is 24 times W divided by 2 times atomic weight of Q. And there was no C before the reaction. And after the reaction in the first experiment, because A is the limiting reagent, there will be no A. A is all used up. And in the case of B, there will be some leftover. So we need to subtract 1 over A times the amount of A used. Because the ratio in the coefficient between A and B is 8 to 1. That's why we are multiplying 1 over A to the amount of A to find the amount of B participating in the reaction. And the amount of C formed after the reaction will be 2 over A times the amount of A used in the reaction, because the ratio in the coefficient between A and C is 8 to 2. And for the volume, if the density increased after the reaction, the volume decreases with the opposite ratio. So if the density increases from 4 to 5, the volume will decrease from 5 to 4. So if the volume of the gases before the reaction is 5 times V, after the reaction it will decrease to 4 times V. And in the gas, the volume is proportional to the amount of gases, so we can make the first equation. The amount of A and B before the reaction is the sum of these two, and after the reaction or when we add the B and C, we are going to add 1 over A times the amount of A used in the reaction. And this ratio is 5 to 4. So we can make the cross product so the sum of B and C after the reaction times 5 is equal to the sum of A and B before the reaction times 4. And from the second experiment, the amount of A before the reaction in terms of mole is 30 times W divided by the molecular weight of A, and the amount of B is 32 W divided by the molecular weight of B. That's 2 times atomic weight of Q, because I'm assuming that the B is made of 2 Q atoms. And initially there was no C molecule. And after the reaction in the second experiment, A is all used up, and the amount of B left over we need to subtract 1 over A times the amount of A used in the reaction. And the amount of C will be A over 2 times the amount of A used in the reaction. And the ratio of the density is 4 to 3, so the volume will decrease after the reaction from 3 to 4. So if the volume before the reaction is 3 times V prime, 4 times V prime, after the reaction the new volume will be 3 times V prime. So we can make the second equation. So in the second experiment, the amount of A and B before the reaction times 3 is equal to the sum of B and C after the reaction times 4. Let's open the parentheses in both reactions. For the first reaction, first equation, so we can all cancel this W. So from the first equation, the first term is 60 over MQ plus 1 over 8 times 75 over 2 times NP. On the right side, the first term is 30 over NP plus 48 over NQ. So if we make the factoring with NQ and NP, 12 over NQ is equal to 1 over NP times 30 over 75, 30 minus 75 over 2A. And from the second equation, if you open the parenthesis, the first term is 45 over NP plus 48 over NQ. That's equal to 64 over NQ plus 1 over 8 times 60 over NP. So if we make the factoring with NP and NQ, 16 over NQ is equal to 1 over NP times 45 minus 60 over A. So let's make a cross product from this with this equation. So 12 times NP. So in both the equations, we can find the ratio of NP and NQ. So from the first equation, NP over NQ is 30 minus 75 over 2A divided by 12. And from the second equation, NP over NQ is 45 minus 60 over A divided by 16. And then we can simplify these two ratio. Let's make the cross product. So 120 over 150 over A is equal to 135 minus 180 over A. So that means 30 over A is equal to 15. And that means the value of A is 2. And if A is 2, MP over MQ is 45 minus 60 over 2 divided by 16. So 15 over 16 is the ratio between MP and MQ. And finally, we want to find the coefficient A times the molecular weight of C over molecular weight of B. So the coefficient A is 2 times molecular weight of C is 2 times MP plus MQ. And molecular weight of B is 2 times atomic weight of Q. So that means if we cancel these two, so let's say the atomic weight of P is 15 and atomic weight of Q is 16. So the value is 46 over 16, and to be simplified, that's equal to 23 over A. So the right answer is the choice 2. So that's it for this video, and thanks for watching.